I have two shuffled decks. If I reveal one card from each deck like this, what's the probability that if I exhaust both decks, that I would get at least one match? Let's find out. Now, only two possible events can happen. There are no matches, or there's at least one match, so their probabilities will add up to 1. So here's what we're going to do. We are going to find the probability of no matches, subtract that from 1, to find the probability that there's at least one match. Now, for no matches, what we're looking for are called derangements. No element is assigned to itself. Let's take a look at a smaller case, where each deck has 3 cards, ace, 2, and 3, all the same suit. The order of the first deck, really doesn't matter. And there are 6 options for how to arrange the second deck. And out of the 6, 2 are derangements of the first deck. Ace, 2, and 3 are not in positions 1, 2, or 3, respectively. And here's what it looks like with 3, 4, 5, 6, and 7 cards in each deck. Here are the number of derangements, the total outcomes, and when we divide these quantities, we get the percent chance of getting a derangement. And we can see that with more cards, the closer and closer we get to a specific percentage. Now you might be asking, how can we find these numbers? And luckily, there's a formula to find the number of derangements of n elements. We can call this the nth subfactorial, which is given through the nearest integer function of n factorial divided by e. So if we want the 4th subfactorial, we would do the nearest integer function of 4 factorial divided by e. That's the nearest integer function of 24 divided by e. 24 divided by e is around 8.829, so the nearest integer to that is 9. Now let's go back to our 52 card deck example. Probability is desired over total, desired being the number of derangements, and our total being 52 factorial, because that's how many different ways we can arrange 52 cards in a deck. And when we divide, we see that we would get around 1 over e. So there's around a 36.79% chance that we would get a derangement. And by the way, I would argue that with 7 or more elements, we can basically say it's around a 36.79% chance we're basically already there with 7. Now, we are almost done. When we subtract 36.79% from 1, we see that the probability of getting at least one match is around a 63.21% chance. So was this surprising? Did you think that it was higher or lower than this? Let me know in the comments.